Hi guys, welcome again to my YouTube channel. Guys, let's look at this problem and we read it first. A periodic function is defined by fx equals to x squared from -2 to 2. That is, x is between -2 and 2. Fx is equals to fx plus 4. So that now guys, this is the period that is from -2 to 2. Sketch the graph for fx and determine the Fourier series. Guys, I have already done that, but before we continue, I can show you what to do, but I will now show you really exactly what I did. So guys, when you are doing the graph, you are going to have fx there, and you are going to have x, and then you can divide this one into several parts, because this one, remember, is not a straight line. So you will need from maybe -2, you go to -1, 0, you can go to 1 again, and then 2. Then guys, you can now check when you put -2, here you get, that is 4. For this one you get 1, for 0 you get 0, for this one you get 1, and the last one you get 4. But guys, I have done that. I even drawn the diagram. So this is my diagram, guys, that I have already drawn. And as you can see, guys, this is what I did. I put x to be -2, and then this one was 4, x -1, then fx is 1, 0 for 0, 1, you get 1, 2, you get 4. So when I come to draw, guys, beginning with the -2, I had 4, and so I drew that point. Then -1, I had also 1, which is supposed to be here. We have 2 there, we have 3 there. And then we have 0, 0 for 0. 0 is supposed to bring out fx being 0. Then you come to 1, then that one, the point was here. And for the 2, the point was here. And so guys, this is what now I drew. From this one, guys, you can now extend, because remember, this is a complete period. So to continue, you just need to continue with the same pattern that you had here. And so guys, that is the beginning point. Secondly, guys, now you come to our equations that we need to use. For the equation we need to use, we have the following equations. That is, for the first one is for the series. For the series, you have this equation, guys. And as you can see here, this is nx pi all over L. Guys, I'll show you how it comes about. But before that, we now go to a0. For a0, it's supposed to be 2 all over L, integral from 0 to L fx dx, and then an equals to 2 over L, integral from 0 to L fx, and then this cos nx pi over 2 dx. Guys, let me explain that right now, because guys, we've been used to doing for where you have only cos nx. So we usually write like this, guys. We usually write an or a0 is equals to 0 from 0 to pi. This one, guys, you are given 2 all over pi there. And then we have fx like that. That is for an. We have fx and then cos nx. So guys, having that, we can change it into the length. Remember, this is L is the length. So that's what we do. This one can also be equal to, in this case, L is represented, should be represented by pi. So that now we write, instead of now pi, we write 2 all over L. Because remember, L is half the period, just like you have pi is half of 2 pi. So this one will be 0, and you have L there. Then guys, we shall have here, this one will normally be Fx, like that. But now guys, when we come here cos, we shall do like this. Already guys, we have said, whatever is here, that is, we leaving out 2, it is the same as 1 all over pi, is equivalent to, now you can leave out 2, this is 1 over L. Now guys, we want to find out, because n is already there, we can say n is already there. Now we want to find out what is now equivalent to x. If you were to put x there, we do what we call cross multiplication. And then when you do that guys, we are going to have x multiplied by 1 all over L divided by 1 all over pi. So pi is going to come up there. And so guys, we are going to have here, we shall write pi x all over L. So that's what now is going to be represented here. So when we come to changing from degrees, now we come to the length. That's how guys we do it. And so we get something like that. And so that's the explanation for the change of from degrees, that is 0 to pi, and now changes from length 0 to L. For this one now you shall put it like that. Guys, we continue. Now we've been able to establish that, and that's why we have this nx pi all over L. Now coming to that guys, we have now first of all to establish what is our A0. Our A0 is given by that, and the L already we have is 2. From the equation there, we can see that our L is supposed to be 2, or 0 to 2. This is where we are now integrating from 0 to 2. So our L is supposed to be 2. So therefore we write like this, 2 all over 2. And then we have the equation there, x squared. And finally guys, we're going to get 8 over 3. So our A0 is 8 over 3. Guys, now coming to AN. Still we have 2 all over 2 from 0 to L, and this L is supposed to be 2. Guys, this is supposed to be L equals to 2. Now we integrate fx cos n pi x all over L dx. That one we use what we call, guys, integration by parts. And so when you do the integration by parts, this is what we are going to find. We are going to find something like this, guys. We are going to have our u now being equals to x squared, and then the dv here, guys, as you can see here, we have this. We have u being x squared, then this cos being dv. So we shall now have written that is x squared and then the dv. Then the du, we are going to get that. And for the v, guys, this is what we are getting. So we use integration by parts. Once we do that, guys, this is what we shall get. This is uv minus, now this is du. Du, you have to x, one of the two here, and x, and then we have v. Another 2 sine that all over n pi. That's what we have. So guys, from there we still need to do another integration by parts for this. Now for this, guys, you can have now the u, and then you have the du here, and then for dv you can integrate that, and then this is what you are going to have. And so when you have that, you're now going to replace here, guys. This is the first term we had for here, and for this one you have here, you have the u, here, and you have the v. Now this is supposed to be minus integral of v du, and this is now the integral for v. The v is here and it is also here. For the du, we usually have we have here du as 1, so it is not put there because it is 1. So this is the du we are going to integrate. Here we are supposed to have a dx. Guys, from there now we come and have our solution here. After we integrate, this is the term and this is the same term. For this one you have to multiply there, you get that. And lastly here, after you integrate, this is what you are now going to get from cos. You come to sine. Guys, when we arrive there, noting that this is a cosine Fourier function, these ones are going to be 0. For the sine term, it will become 0. So that one is 0. And this other term is going to be 0. Guys, you can try and see if you put your 2 here. You'll have, for example, now if I put 2, I'll have sine n pi. If you press 1 here, it will be sine 180, which gives us 0. If you press 2, sine 360 will still be 0. And then when you press 0 there, you get 0. The same case with that. And finally, guys, this is what we are going to get. This is what now is going to give us the value. And remember that this one now is going to, for 2, this is going to be 16. And when you put 0, guys, the 0 will be able to cancel. When you put your limit as 0, you'll have 0. So when you put your limit to be 2, this is what you are now going to have. That is 16 all over n squared pi squared cos n pi x all over 2. So guys, when now I come and test and put n equals to 1 for this, you'll get an negative 1. That is n, that is, you have n being 1 there, all over 2, and then you have pi and x. Okay guys, before we come to that, guys, you have to replace for x. So this one would have been equals to, now we put 16 all over n squared pi squared, this is squared, then you have cos, this is cos n pi all over, it's actually n pi like that, because if you put 2 here, the 2 will cancel this, guys. And so guys, you are going to have something like that. So when, guys, we put a 1 here, we will get cos 180. Let's see what we get from cos 180. Actually, I've already done there is negative 1. So if you put now n to be 2, guys, you're going to get cos 360. And that one gives us 1. And so, guys, it will happen like that alternatively. And as you can see, you get negative 1 for 1, negative 2 for 2, that is positive 2 for 2, for positive 1 for 2, negative 1 for 3. And then, guys, from there we come to something here that I want to show you. So for this, if you are to form a series with these ones, guys, these ones forms what we call a GP. And the GP, maybe to illustrate here, guys, for the GP, guys, you have, if this is the first term and this is the second and the third, To have a general equation, this is what you would have. You have the first term, the general equation for GP. You have the first term, which is -1. Then you multiply by, that is, this is the A, then the R is supposed to be 1 because if you multiply -1 times 1, you get 1. So this is the R, and then this one is raised to n minus 1. In other words, this is A, R, n minus 1, like that. So guys, now you can now evaluate this. This one can be given as, this one -1 is raised to 1. So by the laws of indices, this one is now going to be, of course this R is still negative because we are saying the R is -1 times -1, 1, 1 times -1, -1. So both of them are negative. So using the law of indices for that, you have -1 like that, and then you can add 1 plus n minus 1, that gives us n. So guys, this is what we are now going to get to represent our series of odd numbers, not of odd numbers, but of numbers from 1, -1, 1, -1, and so on. And so that, guys, this is what I have found right here. So when now, guys, we come here, we can write now our solution. From our equation, we had A, this is A0 all over 2, now plus, that is our fx equation, A0 plus, this one we have a summation from n equals to 1 to infinity, an, and then we have here cos nx pi all over L. That is our equation. Now we fit what we have found there, guys. This is what we have found, guys. We have found here the 16 is here. This is 16 all over n squared pi squared. But then for cos, it's going to be this. This is now going to represent the cos. And that's what I have done here. And this is not this cos. It is actually this cos that is here. This cos is going to be represented by this. And so as we continue, guys, you can now see our 16. The 16 we are talking about here. And the n squared is here. And the pi squared is here. And the -1 raised to n is here. And then this cos is what is here now. Of course, we have now, this is L is 2. And so it looks like that. And finally, guys, this is our equation. This is our equation. You divide that, you get 4 over 3. And then you continue like this. So guys, thank you for listening to me. Bye bye.